Welcome to the session. Greeting of the day. In today's class, we will see about the programmable logic controllers. We are on the talk of the various devices which is going to do a processing operations and controlling operations and modifications. So earlier we have seen about the microprocessors and microcontrollers. In continuous with that programmable logical devices, we are going to see about the programmable logical controllers, how it is done. So a few symbols also we should understand. Before drawing the ladder program, we should understand few. So it is this symbol it represents. We are going to draw a program. So likewise, I have taken a left rail, power rail. From that, I have connected a line. Power rail is taken. I want to switch on the bulb. So I want to make a switch connections between two, left and right, or power positive, negative, like that we can consider. So I want to make one connection. So here the power rail I am making here, this is named as normally open. It is not connected now. And it is ready, the power circuit is ready. And here I am connecting one output. So this is called as, this symbol represents the output. We are understanding the program. We are not typing the program. Through symbol we are taking and understanding. That is what I have mentioned. Easy to understand the program. So that is like this. So I am putting one output here. And I am closing. So that is what? The left run, left right, right run. So it is one of the rail connections as like this. You see? Left right, right right. From the left rail I have taken the power. On the first run I have created an open contact and one input, one output. All are satisfying, all points are satisfying here. Multiple inputs can take, but only one output. Now what I am doing? Now I wanted to make the connections. I am concerned this is a bulb. I am concerned this is a fan. I am concerned this is a automatic camera. Anything, some output I should take. When this is an alarm also we can take. Some examples. So when the circuit is closed, the circuit is normally open. It is mentioned here, it is normally open. I want to close now. The switch is activated. Otherwise, due to the sensors is activated. Sensor is connected to the switch and this is activated now. How it is activated? It is connected this two. If it is connected this two, the power can go from left to the motor. Until then power not came. Until then sensor is not detected. When the sensor is detected, that sensor gives the information to make a latch here, to make the connection here, and then it is connected. If it is connected, here it is power connection. The power connection now moves there. How? Now it is ready. It is stopped there. When the power is closed, and we are moving from here to here, the power is going here, and power is ready. Now it is going to activate. So now it is going to activate. This is nothing but a bulb, alarm, anything. So it is activated now. So the power is one is over. So accordingly we can do. So this is what I have drawn there. See, input and output I have taken. So when input is activated, now it can come and do. And now the other options, what I can do, other options. So I am naming this as a A input and B. Now I have taken this B connections. I have already programmed. How I am programming like this? I am programming in such a way it is in the closed contact. It is in the closed. It is normally closed. It is normally closed. What happens? This is keep on running. I am naming this as I have this bulb. Therefore, I am naming this as a motor. Right? So when the sensor is detected, it means when the temperature sensor is detected, this alarm bulb should blink. If the alarm bulb is blinked, I have taken this output as a secondary input to the second run of B here. When this bulb is activated, the connection which is normally closed will go into disconnect. Opposite reaction should take place there. If it is open and the sensor detected, it is closing on the circuit. This is on connection. This is off connection. This is normally closed. When the sensor is detected, this connection is going to disconnect. If it is disconnected, automatically the motors or power circuits which is going to disconnect. What happens already, according to by this design, here we have the connection is already moving here. Connection is already moving to the motor. When the bulb is activated, it want to disconnect now. Normally closed, it is going to disconnect. How it is disconnected? This power circuit will off. The power circuit will off now. So it want to run the motor. It want to run the motor, power circuit will cut, therefore alarm, and the people will be, from the rooms we can take exit. And so forth, therefore power terminations occurs there. So likewise simple examples we can do, and this what happens here, with what? You see? So here when it is alarm B is started, this connections will make a disconnection. If it is disconnected, what happens? Motor is going to stop. I have drawn first as normally closed. But what happens? When this B is activated, this is going to disconnect. It means the closed system is becoming the open. This is normally open. When it is circuit is on, this is going to on condition. This is normally, this is off condition. First it is off condition. It is going to on. Here this is generally first in the on condition. When circuit is closed, it is going to off condition. So this is the changeover occurred with respect to simple logic connections. So one by one we have to see. Normally open, output occurs when the input is given. Output is on when we have sensor is detected and input is given. That's the point. And here it is normally closed. Normally closed. Output occurs when the input is not given. I have not touched it at all. Motor has been already running. Power has been already in display. But when the sensor is detected, it is going to disconnect. And there is no supply of power there. So that is what a simple understanding we should do. I am entering into a simple formats of ladder programs. One by one we want to see about it. We want to see about this AND connections. These are logics. Logics are AND logics is there. Then OR logic is there. Then NOT logic, AND or NOT logics are there. One by one we have to see these points. You see, first we will understand one by one. We have taken about AND. AND we know the word one all. It means AND means 1 and 2 is AND. OR means any one is OR function. So I have taken a truth table. I have taken a truth table here. And now this is the electrical connection. So this is the electrical connection. I have a power rail and I have two switches here. Switch A and switch B. And one output connection of any bulb. This is the electrical connection representation of a wiring system, a electrical connection. Now I am changing this electrical connection into the ladder program. This is the ladder program. This is the ladder program I am changing. I have converted this switch 1 into open connection 1. Open. This is open, you see. So this is open, normally open. I have kept open. Switch is not on. When the switch is on, it should on. So, and on in second switch B, I am keeping the normally open. Switches should on, should on. And this output bulb, I have considered here as a bulb. Now what happens? This is case A. Case A, case B, case C, case D. So likewise we consider. So input A, this is input A, input B. Now I have not at all on. The zeros and 1 represents on and off of the switches. I have not on. A not on, B not on, so output not came, bulb not blinked. Second option. Option B, I have on only one switch. It means I have on only one switch here. Only one switch has been connected here. Only one switch has been connected. What happens? From the power rail, the connection is not going there because there is a gap. This switch is not on. Therefore, again the output becomes 0. This is B is not operated. Now, I am leaving this. And I want to activating the B. So I am activating this one and this one, but I have not activated this one. So what happens? Power is not at all come here. Power not came because A is not activated. If I am activating only B, at the time also output not came, bulb not activated. So both are not activated, output is 0. A is activated, output is 0. Only B is activated, output not came. At 3 conditions, output not came. It means AND connections, AND means both. So now I am operating, now I want to operating both. Now I am operating A is connected, the power came up to this point, So power came up to this point now. Power came up to this point now. I want to activate B, then only the motor will receive this red power. See, I am activating B. I have activated 1, I am activating this B also. I have activated B. So what happens? The connection goes to the power supply, it means the motor, and it runs. In our case, it is a bulb. Right? Similarly, in the ladder diagram, I have connected these two. What happens? Therefore, the power goes, and then it activates the bulb, and then it can able to bulb will blink. So this is a condition of AND. Both are activated, then only bulb will blink. So one should come under there. So this is about AND functions. Now we move towards the NAND gate. It means I'm writing this as another format as NAND as not AND function. We have seen AND means both should activate, then only the power output will come there. So we are activating now. If both is true, if both 1 and 1 is true, function should not happen. If any two are not activated, I am not at all touched, sensor is not at all activated, switch is not at all activated, at that time there will be 1. We have seen in the AND table, you see, we have seen in the AND table 0, 0 is 0. But here in the NAND table 0, 0 is 1. How to design this now? How to design this? We see, I have connected earlier in the series connection. It means this is in series, one after the other. It is called a series connection. Now I am connecting in the parallel connection. In the parallel, that is also not the open connection. That is a closed connections I am doing. That is this connection I have taken closed. It is normally closed. Output occurs when the input is not given. I am not at all touched, not at all given, but there is an activation. That is called as here. So not at all touched. You see the electrical connection here. Here already the circuit is in supply. Circuit is in supply. Circuit is in supply. I have not touched. Here also the circuit is going is in supply. I have not touched. Now this is about 0, 0, 1 activated. AND function, not AND function should do. I have activated 1 and 0. You see, there 1 and 0 is 0 because 1 is activated, it is in series, A only activated, B is not activated, power supply not came. But here 1 is activated at the time also, here 1 comes. Opposite to the AND is not AND. You see, I have activated 1. It means already it is in the closed condition. I want to remove this. I want to remove this connection now. So connection is like this. So connection is like this. Here it is disconnected. Here is disconnected. I have disconnected A. It means one is touched, sensed. So I have touched causes the disconnection by the circuit. Touched causes the disconnection by the circuit. Therefore, one I am touching as a given one input here, it is disconnected. It is disconnected. What happens? But even though by the electrical circuit you see, here the circuit is going there as by the other connections. So these things happen and the output is going, 1 is 1. 1, 0, 1, it comes. Now, you see. Now, this, I am touching the B. It means, let us consider now, this is already going. Now I am disconnecting this one. What happens? Already circuit is moving. So see, I am touching the one, it means the touching causes the disconnection, but the connection goes through A. So that also causes the 1. Now what I am doing, touching the both, sensor is activating the both connections. What happens? As per the connection, like this it is available. As per connection, the circuit is available like this. Now I am touching both. I am touching this one and I am touching this one. Right? Connection is not occurred. Connection is stopped here. Connection is stopped there. Connection is stopped there. Therefore, what happens there? Therefore, power supply also not came. So when I am touching this 2, it is going to disconnect. Then obviously this won't form. So this is disconnection. This I am going to disconnect. So this when I am touching this is disconnected. When I am touching this, it is going to disconnected. So the power is not done. The power not came. The power is stopped here itself. This is called as not AND functions. We have to plan whether it should be parallel. We have to plan whether it should be series. The same connection I converted as and not AND functions. The same table you see here 0 0 is 0, but here it is 0 0 is 1. First connection B 1 0 is 0, but here you see 1 0 is 1. So the opposite to the AND is happening. In the AND function 0 1 is 0, but in the AND function 0 1 is again it is 1. In the truth table last one 1 1 only it is activated as 1, but here in the not and opposite 1 and 1 is becoming the 0 function. So this is what a not AND function. This is what only we have seen now. Now I want to explain about OR functions. So this is about the OR. So this is about nothing. We are taking about the truth table. This is the truth table, and this is the electrical circuit. This is the ladder diagram. Right. We have taken. It means OR. Any one is activated, function will open. Any one is activated, function will open. So these two are not activated, these two are not touched. At the time it is 0. We understand. And then now, I am touching only one. What happened? You see, I am touching only one. This I am touching. A is I am touching. Therefore, circuit is going. Activated. It means I am touching here. A is touched. Circuit is going. It is activated. So it is activated. Okay. This is option 1. We will erase again. Right? This connection is okay. Now, what I am doing, I am not touching the option 1, I am touching option B, I am touching here. It means I am not touching this one, I am touching here, I am touching here. So it's 2 is activated. At the time also, circuit goes through this way and activated. In the ladder diagram, I am not touching this one, I am touching here. At the time also, the circuit goes in this way and it is activated. So bulb blinks. Now, that is I have mentioned as 0 1 is 1. First I have touched input 1, upper one activated. Now I am not touching the upper one, but below input 2 is B is activated at a time also, it is done. Now I am touching both. What happens? I am touching both connections. I am touching both connections, you see. I am touching here and I am touching here. What happens? The circuit will flow here and also the circuit can able to go here. Anything it will activate. Whether in the A, it's already activated. The B connection, it can be activated. Similarly here, I am touching A, touching B, both can able to activate this connection. Both can able to activate this connection to B. So connection goes through this way. The connection can goes through this way and also can be done. This is about the OR function. What we have seen about the AND and not AND. First we have seen AND, not AND, OR. It means not happen. It is either one. OR means either one is operated, either one is touched, and output will occur. That is what OR function. Now I am coming to NOR function. It means we are writing as a not OR function. OR function not to be happen. You see, we understand this easily. So 0, 0 is 0. It's not OR. What happens if it is 0, 0? It should be 1 day. You see, 0, 0 not at all activity. It is 1 day. I am planning. So here in this 1 is activated. 1, 0 is 1. But in next diagram you see 1, 0 is 0. Similarly, 0, 1, 1 is activated, then it is operated 1. But in the next diagram you see 0, 1 is becoming the 0 function there. And then in the OR function I have done, 1, 1 is 1. But here you see 1, 1 is becoming 0. For that what I am doing? I am connecting this is in the parallel connection. This is in the parallel connection. OR gate, this is in the parallel connection. Parallel means anyway it can go operate. Now I want to do opposite to this. I have taken the normally closed connections, and I have connected in the series way. Normally closed connections, I have connected in the series way. Now we will see again. I have not at all touched 2, but the circuit is on. You see, I have not at all touched here. But what happens as per the design, circuit is already in closed condition. Circuit is already going. Because it is already closed. So it is going. Now, I am touching 1. What happens there? I am touching 1. Here I am touching. So connection is disconnected. Here the connection is disconnected. What happens? The circuit from the power rail, it is not went to solenoid. So what happens here also? Remaining part also not activated. So everything will become disconnected. Everything will become going to disconnect. So power is not happened. Okay. Now second option. So here it is disconnected. If it is here it is disconnected. Option R will be disconnected. This all is not happen. Right. Now I am touching the B part. Come to the original questions. We can come to the original questions here. So this is the original question. I am not touching this. This is the new question. And I am touching the B one. What happens? I am disconnecting this part. I am disconnecting. Normally circuit is on. Now. Now, instead of touching A, instead of touching here, I am touching here in B. While I am touching B, what happens? This part is disconnected. If this part is disconnected, the remaining part, output is not went to the motor or solenoid, whatever it is. Similarly, in the ladder diagram, by the electrical circuit, I am disconnecting here. When I am disconnecting here, the remaining part is not happen. Remaining connections are not went. So this is about a not OR function. So this one 0. I am touching here, touching the B connections. It becoming 0. It means output not came. At a non-touched portion, output is running. But non-touched portions, output is running here. Right. Now, here by the OR function, both are touched, output is on. But here in the not OR function, both are touched, output should not come. You see, I am touching both. I am touching this one. How? First initial condition, line is going. Initial condition, line is moving. Initial condition, line is moving here. Right? You see, now I want to touch both. You see, I am touching here and I am touching here. Connection is disconnected. So we can able to take both. So here itself, that when you are touching here itself, power is disconnected. And when the base touches, no use. So obviously power not came. 1 and 1, both touching is becoming 0. Not or, I am naming this is a not or. So here also I am touching here, disconnected. Obviously this will be disconnected. And I am touching here also. It is obviously going to disconnect. So it is all not happening. So this is what? It will become 0. So this is how we have to plan for creating the not OR functions. The summary. In today's class we have talked about the PLC, programmable logic controllers, and we have seen in this PLC we have talked about the structure of PLC, and then the various components, and then we have entered into the various ladder diagrams, like programming. And for ladder diagram we have to see about the various logics of various logics of and or. This I have divided into NAND function. This I have divided into NOR function. And lastly we have seen about the NOT functions also. So this is how we have completed in the summary. The remaining part of the subject, we'll see you in the next session. Thank you.